Now having a go at solving this question. In this question, we've been asked to calculate the weight of the ball, the buoyancy force, and the terminal velocity of the ball. So first, we're going to calculate the weight of the ball. So we're going to solve for the force of gravity being applied to our ball falling through the vegetable oil. So we're going to say that Fg, our force due to gravity, is equal to mass times acceleration, and acceleration for weight is gravity. However, we don't have the mass of the ball. We do, however, have the radius of the ball and the density of the steel. Now, density is a measure of its volume divided by its mass. So we can rearrange this for our mass into our equation for weight. We have a ball falling through, so this is going to be a sphere, and we can put in our equation for a sphere. Now we can put all of our numbers into the formula to get a number. This gives us 0.00268 newtons, or 2.68 times 10 to the negative 3 newtons. Next is to calculate the buoyancy force. Buoyancy force is given by the fluid. So as it's traveling through vegetable oil, we are going to use the vegetable oil's density. The formula is the same as what we used before. So our force of buoyancy is equal to rho Vg. We can plug in our equation for the sphere and then plug in our numbers. This gives us a value of 3.083 times 10 to the negative 4 newtons. Finally, we need to calculate the terminal velocity of the ball. Terminal velocity occurs when the sum of the forces is equal to 0, and this is the fastest something can fall when it falls through a fluid. So our sum of the forces is going to be equal to 0, and these forces are made up of a buoyancy and a drag force pointing up, and our gravitational force pulling down. From Stokes' law, we know that the force of drag has a velocity in it, so we'll solve for the force of drag. We have values for the force of gravity and for the buoyancy force, so I'm going to leave these as is, but let's expand out the force of drag by Stokes' law. Rearrange this for velocity, and then we can plug in some numbers. So as I have the values of buoyancy and weight, I can just put them in, but otherwise we could put in the equations for them and solve. And this will give us a number which comes out as being 0.75 meters per second.